Hi everyone, welcome to my YouTube channel. So today we are going to see one definite integral problem. This problem is very important for this year's 12th board examination, and this problem also covers many definite integral properties as well as trigonometric formulae. So let's begin. So over here the problem is that we have to integrate this function ln 1 plus cos x dx from 0 to pi. Okay, so there are many ways to solve this problem, but today we are going to solve it using the trigonometric formulae. Okay, by substituting 1 plus cos x with a trigonometric expression. So let's begin. Let's start recapping with some multiple angles trigonometric formulae. So as we know, right, sine 2x is equals to 2 sine x cos x, and we know that cos 2x equals to cos square x minus sine square x, correct? So over here we have cos x, so we have to 1 plus cos x, so somehow we have to get this formula. Okay, we can directly write this formula, but for a better understanding, to recap some of the formulae for trigonometry, we are just trying to derive it. Okay, so so we know the formula for cos 2x is cos square x minus sin square x. Now we can write is cos square x minus 1 minus cos square x. We can write this, right? As we know, sin square x plus cos square x equals to 1. From here we derive cos 2x is equals to 2 cos square x minus 1. Now, so this is the formula of cos 2x for multiple angles, right? Now to get the submultiple angle, what we can write is cos of x. If you since 2x is an angle, right? So we divide by 2 to get the submultiple angle, so we get cos x. So we divide the angles by half, divide the angle by 2. So 2 cos square x by 2 minus 1. So we got the formula for cos x, 2 cos square x by 2 minus 1. Now to get the answer for 1 plus cos x, what we can do, adding 1 on both sides, what we get is 1 plus cos x equals to 1 plus 2 cos square x by 2 minus 1. Now minus 1 plus 1 gets cancelled, so we get 2 cos square x by 2. Now substitute this value over here, so what we get, 0 to pi ln 2 cos square x by 2 dx. Now from here what we see is this is a logarithmic expression where we have the multiplication logarithmic expression. Like if we consider this as a and this as b, right, so this becomes ln of ab. So we know that ln of ab, we can write this as ln of a plus ln of b. So we are going to separate this based on this logarithmic formula. Okay, so from here we get is, what we get is 0 to pi ln 2 dx plus 0 to pi ln cos square x by 2 dx. Okay, so from here what we get is ln 2, the integration for dx is x, and we are going to integrate it from 0 to pi, plus over here we have ln, and this term is a square, cos square x by 2, so square term is there. So we have a formula for this as well, right? Ln of a square, if we have ln of a square, so we can write 2 ln a, right? We can write this. So I will be taking this out, taking this square term out of the integration. So from here we can write 2 into 0 to pi ln cos square, sorry, cos of x by 2 dx. Getting my point? Now from here what we can do is we can solve this pi ln2, right, plus 2 into 0 to pi. Let's write this term once more for better understanding. Now over here, if you see, we have x by 2 term. Okay, so what we can do by the principle of substitution, we can we can eliminate this term. So what we can do over here is, suppose we consider, let u equals to x by 2. Okay, so what we can write is x equals to 2u, right? Differentiating on both sides, we can write dx equals to 2 du. Getting this point? Now we will be writing this pi ln 2 plus 2 to 0. So we will be not putting the limits now, as the variable got changed, right, by the principle of substitution. I will be putting this limits based on this value. Once we substitute, the limits get changed, right? So I'll be putting that at last. Let's write this ln cos x by 2 dx. So now now we will be dealing with the limit values over here. If you see, right, if x equals to 0, u should be 0. 0 by 2 is 0, right? If x equals to pi, we have u equals to x by 2, so pi by 2. Got it? So from here, what we can write, pi ln 2 plus 2 into dx, we have 2 du. So the 2 comes over here, since this is the constant term. So 2 comes over here, and from here 0 to pi by 2. Let's write this. So from here, what we can write, 0 to pi by 2 ln cos u du. So this is the term that becomes, okay. So what we can write, pi ln 2 plus 4 into 0 to pi by 2 ln cos u du. Okay, now we have to solve this part. Okay, let's solve for this. Let's consider this as some variable like I. Okay, so what we can write over here is, this becomes pi ln 2 plus 4i. Now solve for this I. So we have I equals to 0 to pi by 2 ln cos u du. Okay, so now what we have to do is, now we, as we know, right, there is one definite integral problem, sorry, definite integral properties, where it says 0 to a f of x dx, integration of 0 to a f of x dx equals to 0 to a f of a minus x dx, right? So we have this, we know this formula. So what we can write over here is, we can write this as 0 to pi by 2 ln cos, right, cos, what we can write, a minus x, so pi by 2 minus u du. We can write this becomes 0 to pi by 2 ln sin u du, which is nothing but, this is also I, right? This is also becomes I, because we have this cos u, and we can write this by using this property. We derive ln cos u as also to be ln sin u du. Okay, so this is also I. So what we can write, if we add these two terms, right, this one and this one, what we get, add these two i's, so we get 2i equals to integration 0 to pi by 2 ln cos u du plus 0 to pi by 2 ln sin u du. Now over here, if you see this formula, right, ln of ab equals to ln of a plus ln of b. We derived ln of a plus ln of b from ln ab. Now do the reverse, because this term is present over here, ln of a, ln of a and ln of b. So what we can write, we can bring this together to form the multiplication term, right? Let's not write over here again. So 0 to pi by 2 ln cos u sin u du. Now what we can write, 0 to pi by 2 ln. So over here if you see, right, cos u sin u. So what I can think of from here is, if we multiply both denominator and numerator by 2, we get this term as sin 2u, right? From here, how to solve this problem? By this intuition that we have cos u sin u, and I want to have sin 2u term on the top, so we have to multiply both the numerator and denominator with 2, so that we get sin 2u on top, right, on the numerator. So what we can do, let's multiply 2 cos u sin u by 2 du. From here what we get, 0 to pi by 2 ln sin 2u by 2 du. 0 to pi by 2 ln sin 2u du minus ln 2 0 to pi by 2 ln 2 du. Correct? We get this, right? Now what we can do is, since we know that ln sin 2u du, what we can do is, we can substitute 2u with some value. Okay, let's eradicate this 2u term. Okay, so what we can do, let 2u equals to t, so we can write 2 du equals to dt by differentiating both sides. Now from here what we can write, sin 2u, so it becomes sin t. So I will not give the limit yet, let's write the term ln sin tu becomes t, tu becomes t, du becomes du becomes dt by 2, dt 2 du becomes dt by 2. So over here I will write half, half. Now what we can write is, so this half into integration ln sin of t dt. Now let's calculate the limits. So over here if you see, right, we have 0 and pi by 2 for u. So if we consider u equals to 0, we get t equals to 0, and when we consider u equals to pi by 2, t becomes pi, right? So over here the limit got changed to 0 to pi, 0 to pi minus ln 2 and u 0 to pi by 2. Correct? Getting my point? Now see, now over here we have this term ln of sin t dt. Now remember one property of definite integral, where we say integration 0 to 2a f of x dx equals to 2 into 0 to a integration 0 to a f of x dx, if and only if integration 0 to 2a f of x dx equals to 0 to 2a f of 2a minus x dx. Getting this point? Oh, sorry. No, we do not need the integral over here, right? Just the just the function. We have to check if the function f of x dx equals to f of 2a minus x is there or not. Then we can write this. right? So over here, if you see, right, f of x, so this becomes sin t, ln of sin t. Hmm. Now we have to put this value. Now over here, let's do this over here. F of x equals to ln sin t, right? Ln sin t. Now f of 2a minus x, that means f of pi minus x, what can be right? Ln pi minus t, right? T, if we write t of this, f of t, f of pi minus t, right? F of t and pi minus t. So we can write sin pi minus t, which becomes ln sin t. Okay. So what we can write from here is equals to half into 0 to pi. Let's calculate the so what we can write from here is 2 into 0 to a, 0 to a, it becomes half. It was 2a, 2a equals to pi, so a equals to pi by 2. So pi by 2 ln sin t dt minus ln u 0 pi by 2. From here we get 0 to pi by 2 ln sin t dt minus pi by 2 ln 2, right? Which is, this is nothing but I, right? This is nothing but I. This becomes this. If over here it's just sin t, over here it's sin u. So the variable got changed, but the function remains the same, correct? So over here we can write this as I. So let's solve this again. So from here what we get, 2i equals to I minus pi ln 2, right? This is what we are getting. Oh, sorry, pi by 2 ln 2, pi by 2 ln 2. From here we get the value of I is minus pi by 2 ln 2, right? That's what we are getting, no? I equals to minus pi by 2 ln 2. Now if you remember this, we have this pi ln 2 plus 4i. Now suppose this was termed as 1, right? From 1 what we can write? From 1 we can write pi ln 2 plus 4i equals to pi ln 2 plus 4 into I is minus pi by 2 ln 2. So pi ln 2 minus 2 pi ln 2, this becomes minus pi ln 2. So the answer for this problem is, so the integration from 0 to pi ln of 1 plus cos x dx equals to minus pi ln 2. So this is how we derived the answer. Please drop in the comments if you like this video. Please subscribe my channel, and also like this video and share it with your friends so that everybody gets the knowledge of it. Thank you so much. See you in the next video. Thank you.